Hi viewers, this is Dr. Fathima presenting you the video on data structure. In this video, we will see about DoublyLinkedList, the structure of the node, the operation performed in DoublyLinkedList like insertion, deletion and search. Let us see what is DoublyLinkedList. The DoublyLinkedList, each node contains two pointer fields that contains the address of the next node and that of the previous node in the list. Hence, traversing both forward and backward is possible in doubly linked list. This is in contrast to singly linked list which has single pointer field. This example shows how the doubly linked list looks like. Now let us see how the node in the doubly linked list is represented. Each node in the DLL contains three fields: the data field which contains the data element to be stored, the next field which contains the address of the next node, the previous field which contains the address of the previous node. The diagram shows the structure of the node. Now let us see how to declare and create a node in doubly linked list. Declaration is done using the keyword struct node name. It consists of three components. One is the data which is of type int. The other component are pointers like next and the previous which is of data type struct node. Then coming to the creation of the node, it is done by declaring the pointer n of type struct node. Then allocate memory using malloc function with the size of struct node. Then set the next and the previous field of n to null. Thus, the node is created. Let us see the operations on doubly linked list. The major operations are insertion, which has three possibilities like insertion can be done at the beginning of the list, at the middle or at the end. Similarly, the deletion can be done at the beginning, at the middle or at the end. The other operation is search, which searches whether the given element is available in the list or not. Next, let us see how the insertion is done at the beginning of the list. Here again, there are two cases. That is, the insertion can be done in the empty list or to an existing list. First, let us see how the insertion is done in the empty list. Consider n be the new node to be inserted and the data be 10. The first step is to create a new node. It is done through declaration of node n of type struct node. Allocate memory using malloc function. Then set n.data is equal to 10 and set both next and the previous field of n to null. Thus, the new node is created. This is how the node looks like. Let us see, as there is no other node in the list, the new node is the one inserted first. Set the head and the tail pointer to point to n by setting head is equal to n and tail is equal to n. Thus, the insertion on the beginning is done. Next, let us see how the insertion of the node is done in the beginning of an existing list. Consider the example shown. Let n be the new node to be inserted with the data value 10. The first step is to create a node as usual and set the data as 10. The next and the previous field to null. To insert this new node to the beginning of an existing list, set n.next is equal to head. By this, the next field of n is set with the address of the head node, that is 1032 as the example shown. Then make the previous pointer of head to point to n by setting head.previous is equal to n. By this, the previous field of head is set with the address of the new node n. Here, I have assumed the new node is created at the location 1430, so the previous field has the value 1430. Next, Set n as new head. Thereby, the old head disappears. Thus, the insertion is completed. Next, let us see how the insertion is done at the end of the list. Consider the example list shown. Let n be the new node to be inserted and the data be 10. As usual, create a new node and set the fields by following these steps. Thus, the new node is created. To insert the node at the end of the list, link the old tail node to new node n and new node to n to tail. This is done by setting tail.next is equal to n. By this, the next field of tail will set to the address 1430, which is the address of the new node n. Then make the previous pointer of n to point to the tail node by setting n.previous is equal to tail. By this, the previous field will get the value 1280, which is the address of the tail node. Now, set the new tail to point to n. Observe what happens. Thus, the insertion is done. Next, let us see how the insertion is done at the middle of the list. Consider the example shown. To insert in the middle, we have to know after which node the insertion to be done. So, let n be the new node to be inserted after the node 50 and the data to be inserted be 10. Create a new node and set the respective fields as usual by following the steps. Thus, the new node is created. Let us assume it is created at the address 1430. Insertion in the middle of the list is slightly complicated as we have to set both the previous and the next pointers. So observe the steps carefully. To insert in the middle, we make use of the temporary pointer p, which initially points to head. Make the pointer p to traverse through the list until the specified node after which the insertion to be done is reached. This is done by setting p is equal to p.next and checking p.data is equal to 50. Once the specified node is reached, then make the next pointer of n to point to the node where the next pointer of p points to. This is done by setting n.next is equal to p.next. By this, you can observe that the next field of n will get the address 1280, which is the address available in p.next. Then make the previous pointer of n to point to p. Now you can observe that the previous field will contain the address of p, that is 1140. Then make the previous pointer of p.next node to point to n. This is done by setting p.next not previous to n. By this, the previous field of p.next node, that is the tail node, will get the address 1430, which is the address of the new node n. Now make the next pointer of p to point to new node n by setting p.next is equal to n. You can see that the next field of p will get the address 1430, which is the address of new node n. Observe the link getting disconnected. Thus, the insertion in the middle is done. Hope you got how the insertion is done. Let me continue the deletion operation in my next video. Have a happy learning.